Okay, so with pre-calculus and trigonometry, we deal a lot with triangles and angles and knowing everything we know about a triangle. A lot of times we get to work with right triangles because they're a little more special, and they have a lot of properties that we should be familiar with, one of which being the special case of the law of cosines, which is the Pythagorean theorem, which means in a right triangle, if you have any two, the square of the first leg plus the square of the second leg equals the square of the hypotenuse, with the hypotenuse being the side opposite the right angle. Um, but we need some basics for working with these from trigonometry. So we're going to start with the most basic figures that we have and get our triangles from there. So if I start with a square, which has all the sides are equal, all the angles are 90 degrees, and if I draw a diagonal for that square, I make two congruent triangles. They're both isosceles, and they're going to split that angle to 45 degrees. So all the angles were 90. They're now half of that because the triangles have to be congruent. They have to bisect those angles so that I will have a 45, 45, 90 triangle. In this case, with the sides, the legs being the same length. And then I could find the hypotenuse with the Pythagorean theorem, which we will look at in a second. If I want to have the hypotenuse, say, for a triangle, I can do another diagonal. And in that case, I can work with one of these little triangles. So this case, I drew another diagonal. The angles are still 45 and 45. That means that this angle has to be 90 because all the angles of a triangle have to add up to 180. And in this case, I will have the hypotenuse being the side that's marked and labeled. So we're going to work with these. I'm going to go into a different app, in which case we can see, so I can write my equations and all that stuff. So bear with me just a second. Okay, one of these days I'm going to get better editing materials, but for right now, we will deal with this. So if I have my two right triangles that I took from my square, one with one diagonal drawn, one with both diagonals being drawn, and remember our Pythagorean theorem is a squared, I need to change my color, sorry, leg squared, ooh, wrong size, too small, erase this, sorry. All right, whoa, too much erasing. All right. Erase a little bit. Sorry. Okay. So I know that with the Pythagorean theorem, I have leg squared plus other leg squared equals the hypotenuse squared. And this would be like 1 leg 2. Or a lot of times we think of it as a squared plus b squared equals c squared, where c has to be the hypotenuse, which is across from um, the 90-degree angle. So this would be my C. In this case, I'm going to call it, yeah, I'm going to label it C. All right, so if I'm looking at this triangle, I know that I have the two sides are equal because it's a 45, 45, 90. So I know my legs squared is going to be 16 squared plus 16 squared equals C squared. All right, now being a lazy math person, I am going to make my life a little bit easier, and I would say 2 times 16 squared equals c squared. Knowing that I have to get c by itself, I don't want to do any calculations if I can avoid them. Um, I should know all of my perfect squares up through 20. If you don't, I recommend knowing it because those numbers show up and it will make your life easier. But in this case, I know I need to get c by itself, so I am going to square root both sides. And I'm going to use all of the rules that I have from algebra for this. So I know that this squared will cancel with this, and that will leave me with a c. And I do know that if I have things multiplied under a square root, I can make it into two separate square roots. So this is 2, this is square root of 16 squared. And then I also know that I can simplify things by squared inside with a squared outside becomes just the number underneath it. So then I have 16 square root of 2 equals C. Cool. So this side is going to be 16 square root of 2. I'm going to move my C a little bit. Cool. All right, so any 45, 45, 90 triangle, if I have the two legs of the sides, they're going to be in the same ratio, with the hypotenuse being square root of 2 times whatever the side of that triangle is. However, I don't memorize that. I usually just do the Pythagorean theorem. It will show up a lot, and you will probably end up default memorizing it. But for right now, I don't memorize it. I just do the Pythagorean theorem because we will use the Pythagorean theorem all the time, so we might as well get used to using it. For the other triangle where it was the diagonals and the diagonals, so we have the shorter side, basically the hypotenuse is now the side of that square. That means that this is still a 45, 45, 90 triangle. This time I don't know the legs, and because it's a 45, 45, 90, I do know that it is still isosceles, and the two legs have to be the same, and I can use my Pythagorean theorem because I have the legs marked, I have the hypotenuse marked. In this case, the hypotenuse is the number, so I have x squared plus x squared equals hypotenuse, which is 16 squared. Using the same math knowledge that I have, I know that if I have two like terms, I can just add their coefficients, which are hidden ones. So this is 2x squared equals 16 squared. Yet again, I don't want to deal with big numbers, so I'm going to deal with the 16 squared as it is. I'm going to divide both sides because I want to get x by itself. Divide both sides by 2. Now, I do have to remember my order of operations and what I am allowed to do. I am not allowed to divide this 2 into this 16, even though they are both even, because the 16 has a squared on it. So I'm going to leave it as 16 squared divided by 2. And I'm going to still, my goal is to get the x by itself. So I'm going to square root both sides and use the principle that I kind of did with the multiplication. Works the same thing with division. I can have each one be its own square root. I know that this will become, the top will be 16 squared square root, and the bottom will be 2. So big square root for a whole fraction can become two square roots that you're dealing with. I know that this square root cancels with this squared, and I have x equals this square root cancels with this, and I have 16 over the square root of 2. Now, back in the Ice Age, when I was taking classes, we were told we are never allowed to leave the square root in the denominator. We have to rationalize the denominator. Now, this isn't always the case. Technology has improved, and yes, we don't have to look up square roots in tables anymore. However, we should rationalize the denominator because we are going to be seeing that. I do have to note that a lot of the online homework systems will let you leave the square root in the denominator. I do not guarantee it will always will. So double check with your instructor, double check with your book, double check with your homework, and see if it lets you. But we are going to formally rationalize the denominator here, and to do that, you just multiply the top and the bottom of the fraction by a factor of 1, which is the square root times itself. Remember, the square, anything when it's the same on top and bottom, that's really just multiplying it by 1, so that's not going to change anything. However, it does change the looks of it. So I have 16 times the square root of 2 because they are not like terms, but I can multiply anything together. And if I have the square root of 2 times itself, the square root cancels out and I have itself, which is the 2. And now I can reduce this 16 outside with this 2 outside, and I will have x equals 8 square root of 2. So this is 8 square root of 2, and this is 8 square root of 2. So we have the same ratio. All triangles will be the same ratio. If they are 45, 45, 90 triangles, we will be doing a 45, 45, 90 with a radius of, with a hypotenuse of 1 in just a minute. Okay, so if I have my 45-degree triangle, yet again, drawn, just rotated a little bit. It's still the 45, 45, 90. And this time I'm going to say that my hypotenuse is 1. In which case, I'm still going to have my legs be x and x. And my Pythagorean theorem is going to go x squared plus x squared equals, in this case, 1 squared. So I have, looking at this, I have 2x squared equals 1. Divide both sides by 2. I get the grand total of x equals x squared equals 1/2. Square root both sides. And I will have, skipping a little bit, I'm going to have x equals the square root of 1 over square root of 2, which is the same thing as 1 over square root of 2, multiply top and bottom by square root of 2 over 2. And I end up with x equals square root of 2 over 2. So this is equal to square root of 2 over 2. And this is also equal to square root of 2 over 2. And this will be useful in very short order when we start looking at the unit circle and how we're going to find some actual values of angles and start looking at our trig equations and trig ratios.